Hello beautiful people, today we're going to take a look at a classic coding interview problem, best time to buy and sell stock. It is a pretty easy array-based problem, some thinking is involved, but there are no additional data structures, so it's easy to pick up, easy to master. Alright, let's take a look at the problem. You're given an array of prices where each price is a price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day to sell the stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve the profit, return 0. So what does that mean? We have to choose a day to buy a stock on, and then we have to choose another day in the future to sell it. For each example, we have an array of integers, and each integer will tell us what the stock is worth on a given day. For example, on the first day the stock is worth 7 units, on the second day it's worth 1, the third day it's worth 5. We have to find the maximum distance between these units so we can generate profit. For example, if I buy the stock on the first day and sell it on the second day, I basically lost 6 units of currency. But if I buy the stock on the second day and sell it on the third day, I generated a profit of 4 units. So how can we maximize our profit? Let's take a deeper look in the first example. How can we calculate the maximum profit? We could start off with the brute force solution, where basically we have to compare all of the elements and try to identify what the maximum distance is. For example, if I start off with the first day, I buy my stock on the first day for 7 units and I try to sell it on the second day for 1 unit, I basically lost 6 units of money, which is not great. We want to avoid this. Is there a day after I bought my stock on the first day where I could generate income or profit? There isn't, because there are no higher values in the array after the first day, so I definitely cannot make any income. What if I buy my stock on the second day for 1 unit? We have to remember that we can only sell the stock after the buy happened, so I can't go back and sell it on the first day. I have to go forward. So in this case, I bought it for 1 unit and I want to sell it for 5, which is great because I generated 4 units of profit. Is there a better day to sell the stock? Well, it turns out yes, because if I go forward and I move to this day and I sell it for 6 units, then I generated 5 units of profit, which is much better than the previous ones. So I can't be sure that this is the best day to buy and sell a stock, so I have to go forward and check what happens on the third day if I buy the stock, what happens if I will sell it on the fourth, fifth, or sixth day, and I have to go forward, what if I buy it on the next days. Of course, it doesn't make sense to buy a stock on the last day because you can't sell it anymore. So how is our algorithm going to look like? Well, first we need a for loop to check for the buy days. And after that, we need a nested for loop within it to check for the days when can we sell in the future. Let's try to scribble up a rough algorithm. So we need a for loop, and this for loop is going to iterate through the values from 0 to n minus 2, which means that this is where it is going to stop if this is the 0th element. And after that, we need a nested for loop where this other variable is going to iterate through the future days, which will start from I plus 1 up until n minus 1. What is our profit going to look like? It is basically the maximum of the current profit and the difference between the sell day and the buy day, which means we have to take aj minus ai. And the time complexity for this algorithm is going to be big O of n squared, because we iterate through the whole array with a nested loop. Of course, this is not acceptable on Leetcode by any means, because it will time out. N squared time complexity is just too much for this solution. So we have to find a way to lower it and make sure that we don't do any duplicated work. In order to find the maximum profit, we have to find the local minimum and also have to find the local maximum after that. The hard part is how can we find this local minimum, because it can be anywhere. So what if we introduce a new variable called minimum and say that the minimum is plus infinity? After that, when we go through the array, we take each day and say that, okay, the first day is the minimum so far, it's lower than infinity. And then we go forward, check the second day. Is it worth it to sell this on the second day? It really isn't, because we are going to lose money. But what if we buy on this day? Because this day's value is lower than our current minimum, we can say that replace the current minimum with the second day and go forward. What if we sell on the third day? So we are going to turn it into a profit of 4 units, right? So this is pretty good. Our profit so far is 4 units. But can we do better than this? What if we buy on the next day? This isn't the minimum so far, and if we try to sell it on this day, we only turn it to a profit of 2, which is lower than the current profit, so it isn't worth it. What about the next day? The 6 is definitely bigger than our current minimum, so it isn't worth it to buy on this day. But what if we sell? If we sell it on that day, then we turn it into a profit of 5, which is higher than our current profit, so it is worth it. And the next day, we can turn it into a profit of 3, but this is lower than our current profit, so it isn't worth it. So this is the algorithm that we're going to use here. What we want to do is to iterate through the array from left to right while taking the local minimum. And when we found a local minimum, then after that, we want to find the local maximum. So we have to calculate if the new value is a new local minimum, or we can generate profit. So we need a for loop where I is going to iterate from 0 to m minus 1. And if our current value at AI is lower than the minimum, then we replace minimum with AI. Else, if the value that we calculated turns into a profit, so AI minus the minimum is bigger than the current profit, then we replace the profit with this value. The time complexity for this algorithm will be big O of n, because we only iterate through the array once and we make sure that we don't touch any unnecessary elements. Alright, let's implement this on Leetcode as well. There are different ways how you can start implementing this algorithm. You can start from the 0th element or the first element. It doesn't really matter. I'm gonna start off of the 0th element as the minimum value. And in that case, I want to make sure that my prices array is not empty. So let's create a guard clause for that. If the prices length is 0, then I want to return 0. And after that, I can initialize my profit to 0 and my minimum value to the 0th element of the prices. So I'm gonna iterate from the first element up until the end. And check if this current element in prices is lower than the minimum or not. If it is, replace minimum value with prices, I, and after that, check whether the difference makes a profit or not. And replace the profit. And that's it. After that, we can return the result as the profit. Thank you very much for watching. I hope you liked it and it was helpful. If it was, please hit the thumbs up button or subscribe, leave a comment or suggestion. It's very appreciated. Thank you very much. Bye bye.